Hello students, hope you all are doing well. If we have decided to present you some videos for those who are doing chemistry for their A-levels. Students, in your A-level chemistry syllabus, you have 14 units. So, out of those 14 units, it's the very first unit about atom and its structure. Let's call it atomic structure. Students, we are going to talk about first about the atom and its structure in this video and in the few videos coming in future. Students, it's those fellows who involved in this field, they had a question, problem in their heads, mind. So, it was what these all are made out of. So, then they thought, some of them thought like it's soil, air, water and fire. Those things, building units of these all the things. But it is not logical, right? Okay, some of them categorize the whole things in the universe in a logical way into two, as tangible, intangible, or let's call matter and energy. Those things occupy the space as well as got a mass called, named as matters. The others, rest, those were not tangible, those did not occupy the space as well as no mass were named as energy. So those were the binary oppositions that they categorized all the things they met with. So students, it's matters and energy. So those the pen, board, table, books and such physical things that you would call matters. And it's light, sound, electricity, potential energy, kinetics energy. So those are the energies, types of energies. Then students, this dialogue of what all the things consist of or made out of, it is going to the ancient time that you find thinkers in Greece. It was before Christ, those years. So it was Democritus, the philosopher we call him. He claimed, he argued like, he thought like, when you divide these things around into pieces, you would find finally one small particle that you would not be able to divide further. With that idea, he thought that these matters are not continuous. It's not a continuation you get, like you can't continuously divide them as you never end up. You can't. He told that you would end up with a particle, one thing finally, that would not be able to divide further. How is that? So it is the non-continuous nature of the matter. We call it the discontinuous nature of the matter. Was his idea. Then students, it was another philosopher in Greece, but later him, Democritus. It was in Democritus' works, they are in 420 BC around. So, then this fellow, this new philosopher or the later philosopher was Aristotle, the well-known, right? So, Aristotle told that no, matter is not discontinuous, matter is but continuous. You would be able to divide it continuously. Further, he told that all the things in the universe, in the world, are made out of one thing called hydrogen. Okay, at that time period, it was not Democritus, but his student, follower, Lucretius was there. So they had an argument, or let's call it a debate. There was a famous debate held. They are in Athens in Greece. Okay. So then the debate, who would you think that the winner? So the judgment was given after hearing to each speaker as that audience to letting audience to clap, make a sound for each speaker, the judgment was given based on the sound of the or reply of the or response of the audience. So with the, let's call the popularity of the audience, it was in that time period who won? It was Lucretius, the follower of Democritus. It was the discontinuous nature of matter. The idea won there at that time period. When it comes to the present situation about this continuous, discontinuous nature of matters, what would you think? What is your idea regarding matter? Is that continuous or discontinuous matter? Okay. Students, this matter is discontinuous in its nature. It's we could prove that taking those three physical states of matter. What are the three physical states of matter? Solid, liquid and gases are the three physical states of matters. When you check for the solid, we could prove that its discontinuous nature if we could prove that matters consist of particles and among particles there are spaces. Okay, you take a solid metal, then you immerse this solid metal inside the mercury, liquid mercury. Mercury also is a metal, it's the liquid metal that you find at room temperature. So, when you keep it immersed and after some time when you take it back, you would be able to find some mercury particles there inside the metal, solid metal. So, mercury particles being penetrated there, the solid metal. It's possible. It could be happen only if those solid particles are having some spaces among those solid particles. That proves the solid or a solid is discontinuous in nature. When you take a liquid, let's take water, the well-known liquid. So you add a piece of condensed there inside water. Condensed, it is blackish color solid, but when you dissolve that in water, it could turn purple. Students, when you add a piece of condensed there in water, the purple color would disperse all around. You would find that dispersing or spreading this purple color throughout the solution. It is only possible if the water particles are having some spaces among them. Students, further, if you add NaCl, cresol we call. So, a piece of NaCl inside water, it could get dissolved. It would disappear off, giving the salty taste throughout the solution. When you take a sip, you would feel the salty taste. It's evenly distributed, the salty taste there throughout the solution. So, those observations, dispersing of the color and the salty taste, so are evidences for that a liquid is having some spaces among liquid particles. So therefore a liquid would be discontinuous in nature. Then further, when we go to a gas, the well-known mixture of gas is air, right? Okay, that's what we are in so at the moment. So when you take air there, when someone is opening a bottle of perfume, being here you would be able to smell that. The fragrance smell you would experience that. The scent. So it's possible only those perfume particles, so fragrance particles, if those spread around through air, it's possible only air particles permit through the spaces among air particles, if those fragrance particles could reach our nasal cavity and stimulate our those sensory cells. So then only we would be able to experience the smell. It's similarly when your mother or someone is cooking a tasty food there at the kitchen. Being here, you would be watering, experiencing the smell. Okay. So similarly, when it is kind of unpleasant smell out there, you would be doing this. It's because that particle responsible for the smell, pleasant or unpleasant, is coming there to your nasal cavity. So then you kind of recognize it's pleasant or unpleasant such. So students, these prove that the particles could spread throughout the air as well. Means gases are discontinuous in nature. So these all are about the diffusion from high concentrations towards the low concentrations. Particles spread, distribute. It's called diffusion, simple diffusion. So is an evidence for the discontinuous nature of these matters. Then students, when it is about the particles, those matters are made out of. So based on their particle distribution, we could, as we have already found out, we could categorize matters into three physical states as solid, liquid and gases. Let's find out in brief, let's find out what are these solid, liquid and gas phases and what are the properties they have got differently as to recognize that this is a solid, this is a liquid and this is a gas. Okay, when you take a solid, students, it's you would find particles being packed tightly. So particles packing would be found as a tight packing in a solid. But when it is about the liquid, so in a liquid, particles are not that tightly packed, quite loosely but packed particles you could find in a liquid. What about the gas? In a gas, you could find particles being not packed. It's very, very loose, right? So then it's about the particles packing regarding a solid, liquid and gases when you compare those three physical states. Then students, we could find it out, there are attraction forces. Attraction, like interparticle attractions. Here, packing them tightly, you could find the maximum attraction forces they are in a solid. Then it's moderate. It's like in a gas, it's no attraction forces, but here it's moderate amount of attraction force, right? You could find in a liquid. Then gases are not having, it's very, very low, the attraction forces you find there. Then students, it's the kinetic energy or mobility, let's call it kinetic energy of those particles. Being in a solid, it's being tightly packed. They are having no mobility, or let's say it's just limited to vibrations only. There are very, very small vibrations only. You get there in a solid. Therefore, the kinetic energy is very, very low. They are in a solid. So, particles' kinetic energy, these maintaining certain distances, these particles are moving. So, it's in a liquid you would find a certain kinetic energy which is greater than of a solid. But here, in a gas, it's the maximum, the kinetic energy you get. So, based on these few things, you could find this shape as the solid. A solid would be having a finite shape. So it won't change its shape. It's a finite, certain fixed shape you get for a solid. But when you talk about the liquid, students, liquids take the shape of the container. And when it comes to a gas, gases have no shapes. volumes. So when you talk about the gas, if you keep this in a cylinder somewhere, it takes the volume of the cylinder. Means they have no true volumes, real volumes. Okay. Then it's about the density. Density wise, solids are having the maximum densities and liquids secondly moderate densities, gases are having very low densities. Those are the informations regarding solids, liquids and gases. Comparison could be made based on these properties. Then students, if you could transform a solid into a liquid, what you need to do is you need to increase the kinetic energy of solid particles. Then their mobility will get increased. So to do that, if you need to provide energy. Energy could be provided through heat. You need to heat that. Let's say it is heating on a solid. You could increase the temperature of the solid. After increasing its kinetic energy of solid, there would be a certain moment. Thereafter, it won't be able to further increase its kinetic energy being a solid. It will get transformed into a liquid. That's the solid to liquid phase transformation, what we refer as melting. Melting, we call it melting. Okay, you could make a solid into a liquid by melting. On that, what you need to do is, you need to just heat. Then students, when you further heat the liquid, same matter, its liquid state now, its kinetic energy would get increased, interparticle attractions would be broken, and its mobility would get increased. Increasing, there would be a certain limit that it reaches. Thereafter, when it further increases its mobility, it won't be a liquid anymore. You could do that on heating. When you keep heating, it happens. Students, you could transform a liquid into a gas by heating, so the moment that it reaches the phase transformation is what we call boiling. So you could then transform a liquid into a gas. We call it evaporation as well. Then it's the opposite you could follow. As you transform a gas into a liquid back into a solid. What? It's you could cool it. You could remove the energy. So it's when you remove thermal energy, when you cool that, it is, let's say, cooling. On cooling, a gas would turn into a liquid. What do we call that? We have two terms. Once we could call it condensation, or we could call it precipitation as well, right? Let's call it condensation. So it's further. Let's try to keep it. Okay. So in students, you would transform condensation gas into a liquid. So by further cooling the liquid, you could transform that into what? Into a solid. It's called freezing. Okay. So there will be a certain temperature that it occurs, melting. We call that temperature as the melting point. Melting point is the temperature at which melting occurs. By heating, you could transform a liquid into gas. We call it boiling. Boiling occurs at boiling point. The temperature it happens is called boiling point. So then the freezing occurs at freezing point. What is the temperature that condensation occurs? Let's call it dew point. find a valuable name applied on that. Okay. So then students, there is another phase transformation as skipping the liquid state, some solids could transform straightly into its gaseous state, what we call as sublimation. Sublimation. So skipping the liquid state, straight transformation of a solid into a gas is called sublimation. Okay, these are the things that you need to know regarding those physical states of matters. Okay students, then let's focus on the smallest particle that all the matters are made out of. So it was John Dalton presented this in a theory. In 1806, he was an Englishman as well as a teacher. So the first idea he presented as the atom, that all the matters are made out of atoms. With the support of the word atomus, it was in Latin, word atomus having the meaning of you can't divide it further. So he introduced this word named atom. Atom. So then we are going to find it out his theory regarding the atom. We call it the atomic theory. Atomic theory. Dalton's atomic theory. So in his theory there are, we would call it 4 or 5 points. So then he first said all the matters are made out of those smallest particles called atom. Atoms are the indivisible particle you could find there. So it was the very first point. Then in his theory, the second point it was atoms neither be created nor destroyed. You can't create, you can't produce atoms as well as you can't destroy atoms. Therefore, the atoms are conserved during those reactions, chemical reactions. When you have reactant, it's the same atoms, all the atoms you got there in your reactants are there finally you could find in products. Atoms neither be created nor destroyed. Then in his third point, he told that atoms within one element are identical in every aspect. Chemically, physically, in both aspects. Atoms within an element are identical. Then students, his fourth point was atoms of different elements are different in all the aspects. Okay, it's like when you take nitrogen and oxygen. Nitrogen is different from oxygen atom. From all the aspects, including chemical, physical, all the aspects. So, in his fifth point, he mentioned atoms. They combine in a simple number ratio when they form compounds. The number ratio between atoms would be a simple number ratio. It follows a simple number ratio. Were the points that you would find there in Dalton's atomic theory. They combine these third and fourth together, saying there are 4 points there in Dalton's atomic theory. So we shouldn't kind of bother about the number of points. Anyway, those are the points that you have got. Then it matters whether it's still valid. Up to it was 1806, he presented this theory. So when it comes to the current situation, is it still valid? These all the points. Let's find that out. So let's go back to the very first point. Students, atoms are the building blocks of matters. So matters are made out of atoms. That's true. But aren't they indivisible? Means is that you can't divide these atoms further? It's not right. So presently, if we know these atoms also are made out of subatomic particles, including electrons, protons, neutrons, and some others. Therefore, students, it's not fair to say now atoms are the indivisible particles. You can't divide over something. It's you could divide an atom into electrons, protons and neutrons. So when you come to the second point, atoms neither be created nor destroyed. What would you say? Can atoms be created or destroyed? The answer is yes, you could. Students, it happens during nuclear reaction. Before going there, I will tell you something regarding an element. When you give an element with a symbol, it's there underneath, in front of the element symbol, underneath, you would be mentioning a value standing for the atomic number. Atomic number is the number of protons you find there. It's we call atomic number. The value you would mention here is named as the mass number. So it is the addition of summation of the number of protons and number of neutrons, for the reason that those are the particles, subatomic particles responsible for the mass. Then summation of protons and neutrons we mentioned here, calling it the mass number. If you mention something here, it needs to be the charge of the species as +1, +2, -1, -2. If you mention something here, the value stands for the number of atoms of that type. Okay, you need to know those things regarding an element. Then when we come back to the second point of Dalton, as atoms neither be created nor destroyed, we could disprove that showing a nuclear reaction. So, during nuclear reactions, atoms get changed into some other atoms. There are two types of nuclear reactions. One is the nuclear fission. Other one is the nuclear fusion. So, in one, nuclei associate forming bigger nuclei. It's the nuclear fusion. In the other, big nuclei get split into smaller nuclei. It's the nuclear fission. So, then students, regarding uranium, it's a radioactive element. It's an unstable nucleus, so decays into some other elements emitting particles. Let me show you that reaction. It's uranium having its atomic number 92 and 235 the mass number of protons and neutrons. So then it decays to thorium. So its atomic number would be 90, mass number would be 231. So then the difference here is 2 of protons and 4 of mass unit, means including 2 protons, it's 2 neutrons. So this particle is referred as an alpha particle. So in this way we could write nuclear reactions, balancing those atomic numbers and mass numbers there. So this proves that uranium decays, destroys, as to form thorium is produced, created. Therefore, the second point of Dalton's atomic theory could be disproven. Then students, when you come to the third point, that atoms are identical within an element in all the aspects. So, students, it's chemically it could be true, yes, it's true, but physically, when you have those isotopes within an element, so what are isotopes? Isotopes are within the same element. Isotopes they are having different atoms based on their mass numbers. They are having different mass numbers, varying the number of neutrons there. Still, they are having the same number of protons. Atomic number would be the same, otherwise they would belong to different elements. So, within the same element, when you find different mass numbers based on the number of neutrons being different, so we call them isotopes. So, let me show you. its students, hydrogen is having 3 isotopes like it is the same atomic number of protons, but no neutron here, therefore the mass number is 1. 1 neutron here, it's the mass number 2. 2 neutrons here, mass number therefore is 3. This is called thorium, deuterium, tritium. Are the 3 isotopes that hydrogen is having. This proves that they have different masses, different physical properties within the same element. You find atoms with different physical properties. That is an evidence, or we could use that to disprove the third fact point, that atoms within an element are identical. It's no longer valid, isn't it? Okay, then students, let's go to the fourth point. Atoms of different elements are different in all the aspects. Is that true? Chemically, it seems yes, but physically again, when you find some atoms having same mass numbers, they would have equal masses. Therefore, it's we could disprove the fourth point as well. Students, let me show you that it's a sulfur, chlorine, argon, potassium, calcium. So they would have some isotopes of sulfur, some isotopes of chlorine, argon, potassium, calcium. They have anyway different number of protons like these, but having different number of neutrons as well, they would have the same mass number. For sometimes you would find such isotopes within some elements giving same mass numbers, then they are equal in masses. Okay, in this way, different elements could have equal masses. Having equal mass numbers, those are called isobars. Having of isobars disproves the fourth point, that different elements are different in all the aspects. Then let's look at the fifth point. Fifth point says that they combine, those atoms combine in a simple number ratio. When you consider some compounds like carbon monoxide, carbon dioxide, let's take water, they are having 1:1 ratio between carbon and oxygen, 1:2 ratio between carbon and oxygen, 2:1 ratio between hydrogen and oxygen. Yes, if they are having simple number ratios, no matter. But sometimes it's possible you to have some ratios among atoms are not that simple. Let's take organic compounds, some organic compounds like carbon, hydrogen, oxygen having 17, 36 and 1. Then the ratio that they are having between carbon, hydrogen, oxygen would be 17 to 36 to 1. Is not that simple. So therefore we could disprove the fifth point in Dalton's atomic theory in that way. So students, this shows that all those 5 points in Dalton's atomic theory at the time now presently are disproven. We could disprove those points, 5 points from the Dalton atomic theory. Does it say that Dalton's atomic theory is no longer valid? Isn't it? So actually when you check those back, those each point back, I can show you that though some points in some aspects are disproven, still there is some sort of validity that Dalton's atomic theory is having. So when you reconsider the first point, what's the first point? That atoms are the simplest, or matters are made out of atoms, means atoms are the building blocks of matters, and atoms cannot be further divided, are the indivisible particles. So that indivisible thing could be disproven by the fact that having of subatomic particles. Yes, that's true. But students, when you consider those matters, are they made out of those subatomic particles, electrons only? Oh, are they made out of protons only? Oh, neutrons only? No, right? So it is, those are made out of still by atoms, out of atoms. So therefore, still there is some sort of validity that first point takes. So when you go back to the second point, atoms neither be created nor destroyed, is disproven by the fact that you have nuclear reactions. But students, do we do nuclear reactions in our day-to-day activities? If we are not doing nuclear reactions in our school labs as well as in the society or in any field that we are doing things, we are not using these nuclear reactions. Actually, those are used in nuclear power plants, in nuclear weapons you could call. So in such limited areas, fields only. Therefore, in that aspect, if you continue with chemical reactions, the second point is valid. During chemical reactions, its atoms actually are not formed or destroyed. They are not changed. So, then students, it's the second point in Dalton's atomic theory has some sort of validity. Okay, let me show you the third point. When you go to the third point, it's having of isotopes. Like we got rhodium, deuterium and tritium of hydrogen. So those isotopes were different in mass. But are they different chemically? No, right? So it's those hydrogen is having one proton, means the atomic number of hydrogen is all the time is what? It's therefore the chemical properties hydrogen exhibit, whatever the isotope of hydrogen is, would be the same. They are identical in chemical aspects. So students, therefore, there is some sort of validity still in chemical aspect, not physical aspect, but mass. It's those isotopes would be different, one to another. So, but in chemical aspects, they are still the same, identical. Okay, when you check for the fourth point, having of isobars, as here it was, they have equal masses for different atoms in different elements. But students, they still have different atomic numbers, therefore they are different chemically. And in chemical aspect, they are still different. Therefore, for the fourth point also, there is some sort of validity still. Then let's go to the fifth point, last point. And then atoms here, as it is saying, combine in simple number ratio, simple atomic ratio, was disproven by the fact that sometimes you would find these kind of ratios which are not that simple. Yes, that's true. But students, most of compounds that we are normally using are having simple number ratios. Therefore, though you will find for sometimes you are having such ratios not that simple, it's for most of compounds it's still valid. In this way, we would still say that although it's questionable, those points that 5 points regarding that atoms that Dalton has presented, still there is some sort of validity. Still it survives. So still we could use in a progressive way. Okay, students, those are the things that we have got here in this video to talk about regarding the atom. So in our next video, if you are going to focus on subatomic particles, discovery of electrons, protons and neutrons and such. So it's these simple few points. Hope you have understood those few simple points. So if students, we are going to round up here in this video. So if you find any matter regarding these simple few points, you would question, you could ask questions and you could present your valuable ideas. They are under comment box. Okay students, with the hope that we are meeting you in our next video at the next time. So if we are rounding up, goodbye.